Okay, in the next two problems, we're going to be doing some multiplication and division. And so recall when you're multiplying, you just need to factor every numerator, every denominator, and then cancel. It's very similar to simplifying a fraction. Just you're factoring two sets of fractions. So we look for greatest common factor in the first numerator. There isn't one because there's no b in both, and that's a 1. And since there's only two terms, we look for difference of squares. They're both perfect squares in subtraction. So this is a difference of squares. So this is b minus 5, b plus 5. And we should be getting very good at factoring that. In the denominator, we've got b plus 5 squared, which is already factored. I'm just going to write that as two separate factors for canceling purposes later. And then we multiply by second fraction. Look for greatest common factor for 4 and 20. That would be 4, which leaves you with something plus something. And it looks like if we take a 4 out of a 4b, you're left with b. Take a 4 out of 20 and you get 5, which should look familiar here. And then we have a common factor in the denominator of 2. And we take a 2 out of that, and you're left with something minus something. So take a 2 out of the 2b, and you're left with b minus, take a 2 out of 10, and you have 5. So it's all factored. Now we're ready to go ahead and cancel. So starting here, is there b minus 5 on the bottom? There sure is, so those can cancel. Is there b plus 5 on the bottom? There sure is, so those can cancel. Can the 4 cancel with anything? It sure can. It can cancel with this 2. And can the b plus 5 cancel? Yes, it can. So wow, look at that. That all cancels down to the single number of 2. Okay. So on division questions, very similar to multiplication. We only need to be careful of the division sign. We're going to switch that to multiplication, and we're going to flip the second fraction. But everything else just gets factored and canceled at the end after you flip and multiply. So for the first numerator, um, we have 3x plus 1, which since there is no common factor for 3 and 1, and there is no x in both, that gets you 3x plus 1. In the denominator, this looks fairly nice to factor. There is no common factor since you have 1's and no x's through all three terms. So first term in each would be x. Then we need factors of negative 6. That'll get you negative 1. I believe that's negative 3 and positive 2. And then in the second fraction, remember the denominator will become the new numerator. The numerator will become the new denominator. And so on here, factoring the top will probably be the easiest. There is no greatest common factor. And since there's three terms, multiplies into two binomials. First term in each is x and x. Factors of 4 that add up to 4, that would be 2 and 2. And then for the original numerator, there does not appear to be a common factor through there. And we need factors of 6x squared, which could be 1 and 6 or 3 and 2. And looking at the numerator here, we have a 3x plus 1, which is a high probability since that is a factor of 6, that could be one of the factors down here. I'm going to go ahead and try that. I'm going to put a 3x plus 1 here. If this is a 3x, then this would have to be a 2x, because 3x times 2x is 6x, and if this is a 1, then this would have to be a plus 3 in order for it to multiply together to get you 3. And let's see if we get 11. 3x times 3 is 9x, 1 times 2x is 2x, 9x and 2x is 11x. So now we're ready to go ahead and cancel. This 3x plus 1 can cancel with this 3x plus 1. This 2x, x plus 2 can cancel with this x plus 2. And there is no other x plus 2 in the bottom, so this x plus 2 stays on top where it's over x minus 3 times 2x plus 3. And that is your final answer.